So,
Ja.
hello.
Jetzt geht es weiter hier, ne? In der Konferenz. Alles klar. Bis dann. Ciao. Ja, mach ich. Ciao.
So, let me see.
Good afternoon, Mr. Ram. How are you?
Yeah, I'm fine. Thank you.
Good
Thanks
to
a
see you.
lot.
Yeah.
Hi, Frederik.
Yeah.
Hi, Matthias.
Hello, Marcus. So, guys,
Marcus, have you met Johnny before? I think
Yeah.
we met.
Yeah, we have met.
Yes. Yes. I think, yeah, I met him.
okay. So, I will start with the introduction very soon. I will switch off everybody now, so the speakers should get in again. And so, yeah. Okay. So, today we've got a very interesting talk, and I like to invite or introduce Frederick Fränding. He's the speaker in our talk with his colleague. And please give me the name again. Frederick, you have to make your sound to switch your sound on. Yeah.
I am here, Fredrik Fränding, with our product manager, Johnny Degerman, as well.
Yeah.
Okay, hello. So I will say some words about the company, and then we can start, I would say. So it's very interesting. I'm very happy to introduce you, Frederick, and your colleague. We called it today the Clever Switch. We are talking about switchable glass, and the interesting thing is the company of ChromoGenics from Sweden, which you are part of, has developed a kind of interlayer which is switchable, which allows a very wide range of glass solutions, and it doesn't need a lot of energy, and it can have almost every shape. So this is really nice, and this is something outstanding about ChromoGenics. They started about 20 years ago to develop their system, coming out of a Swedish university, and that was a startup at this time. They've got 20 years of development, and their products they're offering, these interlayer which are switchable, they can be applied by glass processors by themselves. So this is an easy product to handle, and therefore I'm really I'm very curious what you'll tell us about the new system. And also we will hear in the beginning a bit about why does it make sense to have more and more switchable glass in facades at all? You know, people will say, oh, we've got the current system, we had all this whatever. No, there are some good reasons for having it different and for having it straight in the glass. So Frederick, I'd like to hand it over to you.
Thank you very much, Matthias, for that introduction as well. So what I will do, I will switch here a little bit, and then I'm going to share my screen. Bear with me a second here. So hopefully the screen sharing has stopped. Let's try again.
No, it switched back.
It's back, yeah.
No, we don't see it. We had it before, but we don't see it now.
Let's try again here then. Share screen.
Here we go. Okay, here we go. Here we
Very
go.
good.
Oops.
Now it's gone again.
Yeah, it seems to be that it doesn't want to.
So here we are.
So hopefully now the technology is with us and that you can see my screen. Thank you, Matthias, again for the opportunity. We will talk about the clever switch, as you very cleverly put it, Matthias, and why smart, dynamic, and switchable glass is something to take a look at. Shortly, you have already introduced our company, so I will not do that. We are in the smart switchable glass field with the patented technology where we work on create a dynamic foil built up of plastic layers, and I'll talk a bit more about that. So that's sort of the unique niche for us. We are a Swedish company. We are founded from like the Swedish research field here in Uppsala at the Ångström laboratory. And we've been around for about 20 years. And since about a year back, we are now in commercialization phase of our product. So to take a little step back, I think it's clear to everyone that society is now changing rapidly and needs to do so for us to become sustainable and to save this planet. And where we've seen previously a lot of talk and a lot of noise around sustainability and the need for it, that has really translated in now to frameworks and rules and regulations on international level, national and local levels that are really driving the industry now in a completely different way. The new nomenclature from EU is one example, and there are many examples of frameworks now that are really accelerating the change in a sustainable direction. Population is increasing and urbanization is increasing, and this is going to lead to more real estate being built, more glass, which even increases the requirement for a more sustainable way of building. And looking at the real estate sector, it's a big part of the global energy use and the global CO2 emissions. And if the real estate industry is not changing, energy uses and emissions will increase by 50% in 2050. And so this trend needs to be broken. And a lot is being done, clearly, but new technology is absolutely required to break this trend. Another part that we have talked less about is the social factors and the importance of the indoor environment on human well-being. A lot of us spend 90% of our time indoors today. The combination of sufficient daylight and views has a very important impact on our well-being. We see this now more and more in the importance of attractive properties for employer branding and to get workers back into the office, starting also to affect property valuations. And also in certifications where the well-being factors are in center, such as the WELL international standard. But to take it back, if you talk, why do we have buildings and properties in the first place? And if you ask Google, which everyone does these days, right? It's to provide shelter for weather, for wind, to protect us against cold and heat. Fair enough. So, but why would we need windows then? Is there any reason for that? Well, according to Google, we do need windows because we must provide daylight and views, which is absolutely needed for our health and well-being. So a very engineering conclusion then to this is that we should build properties with very good insulation for protection for cold and heat and wind, and with very large, bright glass sections to maximize daylights and views for our well-being and for the attractiveness of the property. All good and well. The problem, of course, as you know, from your industry, is that it's just not feasible. Good insulation in combination with large glass sections will lead to too high indoor temperatures, too high cooling requirements, requiring an immense amount of costs in electricity and cooling. So we can't do it. So the solution then is some type of solar control. That's where we need. But I think it's important to remember what the purpose of a building is. I mean, we need to provide insulation, comfort in that sense, and we need to provide daylight and views for our well-being in these properties. So what are some of the approaches to solar control? Because this is a must to manage this. You can go the static route, where you can provide good insulation for sure. You can get good daylight views. You can get average daylights and good solar control, or good solar control and average daylight. You can't get both. You're always a trade-off there when it comes to some type of static solar control. You can go to a traditional dynamic solar control with some sort of automated awning and external or internal blinds, where you can provide any insulation you need, good solar control, but you're always going to have problems with both daylight and especially the views, where your automated external solar control will get in the way. So now for some years there is a third option, which is then a dynamic glass and a dynamic solar control, where you can provide sufficient installation, sufficient daylights, undisturbed views, and of course a good solar control. So this is something that more and more architects and real estate companies are starting to look into and use as well, to avoid these trade-offs. So to sum up a bit, why look at dynamic glass in the first place? Well, to sum it up, you can say it's the possibility of getting the amount of sunlight you want when you want it, and at the same time the ability to maximize the views and the amount of glass in the facade as well. Doing that while at the same time having the possibility of blocking up to 90% of the solar energy, so you can control the requirements for cooling. And it's the solar energy, and that is really the problem when it comes to the environmental footprint, because it's the solar energy that you need to cool off with air conditioning, which is very commonly using electricity which has a major CO2 impact. So that's the chance to reduce that impact and also to reduce your climate impact in the same way. So if we look at some of the academic work that is done now on dynamic glass, you see that you have a possibility of doing some quite substantial reductions on energy consumptions, which leads to lower operating costs and CO2 emissions and so forth. But what I think is even more interesting and that we haven't talked about so much is the importance of sufficient daylight in combination with views and contact with the surrounding environment for our well-being. And there are a lot of studies now coming in that field. I've taken some numbers here from a study on people working in call centers, where we have the study made comparisons between a call center group working in an environment with a sufficient daylight and views of the surroundings, and with a control group, where you saw some quite substantial improvement in cognitive ability, productivity, and also reduced risk of some risks of depression and sleep. So with dynamic glass, you can reduce your energy footprint for the environment and costs, but you can also improve these well-being factors. And I think both are two factors for the future that's going to increase in demand. And for you, and we're looking at the market. I mean, if we start with the insulated glass market, I mean, we see some quite rapid growth in that market too, driven by, I'd say, similar trends as is driving the smart switchable glass market as well. So we are looking at some quite rapid growth here the coming years. And I talked about some of these frameworks and regulations that are coming that are also changing this industry. The latest one being the Inflation Reduction Act from the Biden administration in the US. That came now in August, providing a 30% tax rebate for switchable dynamic glass.
All right.
Which is going to change things in the US, and I think there's things going to happen here in Europe as well. And there are lots of things happening on an EU and European level as well. So let's look at a few different, there's a lot of text here, but I'll talk us through it a little bit, because there are different approaches to switchable glass and to dynamic glass. The front runner is really the electrochromic glass and the electrochromic glass units. I'll talk a little bit more about that. That is expected to be the dominating technology for real estate facades. There are some good advantages. There are some drawbacks too when it comes to the environmental footprint and flexibility, but it's definitely the front runner. So I'll get a bit more into that one. But then we also have the photochromic and thermochromic technologies where the glass tints depending on the amount of sunlight or the temperature. There are some interesting technologies in that field. The drawback being that you can't actively control it. We think that is something that users will want to do. And we don't foresee the photochromic and thermochromic really being a big part of this market. Then there are some other interesting ones, liquid crystal being one, which is a very nice high-end product, which there will certainly be a space for that in industry. It's got the price tag, it's got a quite energy-intense production method, and there are some limitations in the solar control aspects of it, also the glass selection and the build-up. But a very nice high-end product. And lastly, SPD, which is also very interesting. You can get very quick switching, very suitable for automotive, I would say. But there are some other limitations when it comes to glass size, shapes, and also appearance, actually. In addition to that, the environmental footprint of the production is also higher than others. And then last, PLC film, which is not really, we don't consider it to be a solar control solution, but it's a good, I wanted to include it anyway, because we see it as a privacy film and a good solution for privacy requirements indoors. But some real limitations when it comes to light transmission and clarity. So not choice for solar control, but a good solution for privacy and other requirements. So then go into especially electrochromic glass. How does it work? The electrochromic function is created. It's basically working as a thin film battery. So we create a positive film and a negative film, and in between the positive and the negative layer, we have an electrolyte that can help change the amount of energy and sunlight that passes through the surface. And we can adjust those properties by applying an electric potential over the positive and negative surfaces. So that's the electrochromic function. So basically think of it as a thin film battery that you can see through. You can create this function directly on glass, where you have two electrochromic glass surfaces and an electrolyte in between. There are a couple of companies that do that successfully and commercially in industry. or you can do it the way we do it, where we create this electrochromic function in a plastic foil instead. The function is relatively similar. It's controlled in a similar way. The switching time is in the range of 20 minutes, but you can see the effect much quicker than that. And you control this with some type of control system that you can integrate with the building management system or an automated system of your choice. And I think some of the key benefits here is the light transmission properties, the clarity. There's no need for service maintenance, and it's a completely silent, passive technology that is built into the glass, which is nice. So this is what we're working on and working with. And when it comes to us, then we build this up in a bit of a special way. So we build this foil up, and I think we can look at that when we have the slide here, where we manufacture two electrochromic plastic foils that we build together with an electrolyte to complete an electrochromic foil that we then in turn laminate into glass. So a number of layers that build this function up. So then the question: why go through all the work with a plastic foil when you can do it on glass directly? Well, there are some inherent advantages of this that we see. One important one is that manufacturing these foils on plastic gives us a much lower environmental footprint and sustainability footprint. So we can do it in a very energy efficient way. We also have the potential to mass produce these dynamic electrochromic foils and provide it to local glass processors who can laminate in the foil themselves locally. In that way, we can provide a technology for the glass processing industry, and we can avoid costly and risky and unsustainable transportation of complete glass units around the world. We can instead transport a low weight foil to the regional and local glass processor who can apply it themselves. Working on a foil also gives us a lot of freedom. We have a very high degree of freedom when it comes to the dimensions. We have a limitation in width, which is around the 1600 millimeter mark. That is our manufacturing setup. But the length is only limited by the size of our autoclave. So depending on the size of your autoclave, you can go in almost in any length. Here we have 4.4 meters, but it's possible to go higher as well. And with the foil, we can cut foil and glass to shape. We work with triangular shapes if you want. We have done round glasses as well. We can do cutouts and shouldn't say any type of shape, but most shapes we can do, including curved glass as well. You know, where that is necessary. We're also completely flexible to adding other function into the glass unit, anti-condensation, sound, safety, whatever it could be. It doesn't really matter for us. You can add it and combine it with any other feature. And really any glass build-up, you know, different thicknesses or different glass combinations, we can have a high degree of flexibility. And with that, we can also provide very good insulation, you know, if we choose a glass build-up in that way, which we typically do, to provide a very good insulation in combination with very good solar control, gives the end user a good final product. And we were talking a bit about this before, maybe even before the presentation started. Yeah, go ahead.
I have one question. You said it's the size of the glass is only limited by the width of, but also do you can use an autoclave or do you can also use the sack system? You know how can it be laminated?
We have used SAC system as well, but we use an autoclave system.
Yeah.
You want to comment a bit more on that, Johnny?
Oh, it's I think it's preferable to use autoclave. We have tried a lot of different methods during the years, and that's what we think is the best and safest way to laminate.
Okay, good. Yeah.
Exactly, but it's the same type of autoclave that is used in industry. That's definitely a possibility. We talked a bit about the energy consumption of the glass itself, which is extremely low. That means that we don't need to feed it a lot of energy and electricity, and we can generate enough energy and electricity by putting a small solar panel or solar cell in conjunction with the glass, and in that way we can create a totally wireless installation where we communicate wirelessly with the glass, and we generate enough energy to run the communication and to power the glass, which is a nice advantage as well.
So that means there's no plug and nothing needed, which
No,
is the problem with the other systems, I would say.
yeah, exactly. You can choose. It's a little bit what you want to do. We can go completely wireless, and then we always have wireless control. We don't use wires for controlling the glass anymore. That is a thing of the past. Sometimes we use we get for new projects we can get power from the property. It's easy and it's not a problem. So then we can get just power from the property, or we generate our own power, and then we either do it as you can see here on the right we integrate a little solar panel somewhere on the frame or somewhere on the facade to just give us enough energy, and we can do that with integrating larger facade systems as well. So that's a possibility.
Okay.
Either we power it a little bit from the property, or we go completely wireless, you can say. And there are lots of possibilities now, maybe I should say as well, now with integrating with all other sensors that are now in buildings, temperature and climate control, and the glass and the switchable glass quickly become one of the smart things you want to control with your building management system, and you can integrate all of this into various systems in quite simple ways now, because the data is in the cloud and we can just build the interface. So when it comes to why we think it's the smart way to go with laminating this function into glass rather than applying it on the glass itself, it's because there is a very competent glass processing industry out there that have a high competence in providing glass solutions to their customers. That is not what we want to do. We want to provide that industry a new technology that they can build in themselves in glass. Starting up, 20 years ago as a small company, we have covered the whole value chain ourselves, even been out installing windows and creating building IGUs and so forth. But as we mature and grow up, you can say, we are focusing more and more on the dynamic foil, the smarts and the intelligence and the controls of that, and working with competent quality companies in the glass lamination and glass processing industry to build this in, minimize glass transports, and providing a quick service and quick go-to-market for the final solution. So we are not there yet 100%. We have started this with a couple of companies, but this is really where we see the future in this technology, where it can become yet another feature and function that your local glass company, glass processor can provide you. maybe I'll skip this. This is the heart of our production. Maybe I can just show the machine. It's where we do this roll-to-roll sputtering and create these electrochromic films and materials. It's a rather large investment where we do this roll-to-roll vacuum PVD coating. It's a very efficient way of producing because we can run 1,500 meters of a plastic roll in one go, in one vacuum. So we can run this in a very, very efficient way. The production capacity is huge. We are not there yet. We are starting out now, but we have an immense potential in the installed base that we have now. So the possibilities are there. I know time is running. I'll just quickly just show, maybe 2 examples of what can be done. This is a project that we have just finalized. Here they wanted to maximize views, and they wanted to build with 75% glass in the facade, while at the same time reaching BREEAM excellence. And you can't do that without new technology. So there we were a part of this with a dynamic glass and a very energy efficient glass solution who helped them achieve their goals. And maybe the other end of the spectrum, we've been working on this not as fancy office building from the late 60s where they had too high energy consumption. They wanted to do a step in energy efficiency improvement in a quick, sustainable and non-intrusive way for the tenants. So we've worked with the property owner to replace the glass, reuse the frames and windows, keep the tenants in the building, and get a relatively quick improvement in energy efficiency. So we actually were able to reduce this building 48% and also get a nice improvement in the indoor environment.
So how did it take place to change these things?
We actually, because we wanted reducing the sustainability footprint was an important part. We actually rebuilt the window frames in the basement of the property, which was a nice part. Built in a dynamic 4-glass unit and replaced them section for section in the property.
Okay.
So it was as one example, and in this case, the windows run completely autonomously. They are powered with this little solar cell, and each window is autonomous. Normally, you want to be able to control the whole facade, and then we have a system where you can control all the windows together. It depends on what approach you want to take a little bit. So with that, time is running, so I'll just sum up a little bit. I say it's clear that the real estate market needs to change. It needs to take some serious steps in a sustainable direction, and to do that, they need technology. We see that the dynamic glass market is growing. For facades and property, I'd say electrochromic is the way to go. That's going to be the dominant technology. Energy efficiency is the key. Many of you are in Germany. We are suffering in Sweden in the same way from this crazy electricity prices. This is driving change. But well-being and indoor climate is also going to increase in importance. And this, I think, can be an interesting opportunity for the glass industry to take part in this technology shift. So with that, we open up for questions and feedback and reflections.
Yeah. So thank you very much for that. That was an interesting lecture. So I'm happy that you gave us these interesting facts. What I find quite interesting, you named it, it's just like we are at the transition point somehow with all this energy crisis, which I see it's at the moment everybody is shocked, but it also will be a really big opportunity to get on, to bring really the system on the market, which some of them, I mean, you're working 20 years on that. There are other system, vacuum glass, whatever, which is on the market, not on the market, but it exists for a long time. Nobody seemed to be interested. Now it's the time for these things to come. And especially when you say there's so low energy consumption that you can have a little solar cell somewhere, this is fantastic. So thank you for your lecture. And maybe Yoma, you like to take the first question?
Yes. Thank you. Can you hear me?
Yep.
Yes,
Okay.
yes.
Yeah. So this was very interesting. Thank you very much, and hopefully we can discuss a little bit more in this one later. Anyway. What's getting, you say that you need to have a wiring, of course, why we needed that one and what kind of wiring we needed if we use a wiring, or if it's a wireless, and if it's a wireless, do you need a battery over there, what you're charging? If you can clarify a little bit those one.
Yeah, absolutely. That's a good question, Jorma. And of course, when we work with different partners and companies in the glass industry, I mean, one question we get is, hey, we received this glass, but there are cables coming out, of the glass. So that is a part of being an active switchable glass. So out of the glass unit, the laminated glass unit, there are cables coming out. We have a couple of different choices how we handle that. Normally, what we do, we put a little control box close to the glass where we put the wires. This control box itself communicates wirelessly. There are today very energy efficient communication protocols like LoRa, for example, which is an excellent communication protocol that we use that need very little energy. But of course, then we need to power the communication, we need to power the glass, and there we have a choice. Either we feed it with 24 volts from the property, which sometimes for a new project is quite easy, or we put a small solar cell somewhere on the facade or somewhere on the window to provide enough energy for switching the glass and for running the communication. So with our technology, we have that advantage that it requires very little energy, so we can do it in that way. Yeah.
Okay, good, very good. And basically, you mentioned it that it's used only very little power anyway to changing the transparent to non-transparent things, and you can let's say to stop that one whenever you like it. But what was how many watts you needed per square meter in this one approximately?
I'd say we haven't sort of communicated that, because there is a lot of know-how and IP around how we control the glass. But let's put it this way, that it's a couple of watts, low level, extremely low levels.
Okay, so it's not the issue at all. But why you use a foil? Everybody uses the glass to put it a coating on a glass, and you have it a total different, and you have this extremely nice roll-to-roll coating, which is of course energy efficient way to do with that one. But can you open up that one a little bit more?
Yeah, I'd say there are two main reasons that we have this approach with the plastic foil. One is being a Swedish company, both from our owners and everyone working here, sustainability is something that we are passionate about. And we're serious about wanting to help the real estate industry reducing environmental impact. And to do that, of course, our product must be sustainable as well. So by using this technology, we can create this function in a very sustainable way, using very little energy, both in the production and in the transportation and in use. So that's one part. The other part is maybe a bit more business oriented. We have the potential to mass produce the plastic foil here. So we can have a very scalable business model. If you do the coating on glass, which is it's a perfectly good solution, you need a complete glass processing factory that you need to build somewhere with a very substantial investment. That business proposition is not as scalable. So we have the potential to scale in a different way by us providing the plastic foil and working with the glass industry. So that the second is a bit egoistic reason, you know.
Okay. Perhaps Matthias, you have it something.
Yeah, I would like to come back again to the shapes and how is it? How do you work with it? You know, I mean, you said you can make most every shape. So how, if a producer of the IG unit or of special glass for facades, how would he use your foil in practice to make, let's say, a shape which is out of the 90 degrees angle?
Yeah. So I'll start out, and maybe Johnny, then you can add on. Where we are today, as I said, we have started now with two companies to started them out on laminating in our foil in their own glass solution. So we still have a little bit of way to go where a local glass processor can themselves cut out any shape they want. We can do it here in Sweden today, and part of our technology and our know-how is how we can cut out these shapes out of this foil. So we have a special process for that. So we have a very high degree of freedom for preparing the foil. Then, of course, you need to match the glass as well to provide the complete solution. Do you want to add to that a bit, Johnny?
No, yeah, as you said, it's not harder to cut in straight angles than in curves in our production. So this isn't a big problem. It's then you go forward with the customer is to do the right drawings, so you do the drawing from the glass correctly, and that we of course help with also. So it's not that different than doing a rectangular glass, I would say.
Okay.
Yeah.
And how do you cut it? Do you use a cutter or how is this done?
We have some know-how and technology there for how to cut this foil, which are sort of part of our trade secrets. But there is machinery available, and then there is a bit of intellectual property for how to apply it in the right way. For how to cut that, that's of course a very, very important part of the function.
Good, thank you. And now my final question is: how do you think is the EU market or the world market for switchable glass in terms of in comparison to regular standard IGUs?
Yeah. No, it's the $1 million question, you know.
Well,
I think that, you know, the challenge for us is we get a lot of interest now, which is great because we've seen a change now for the last 1 or 2 years where the maturity and understanding has really increased a lot.
yeah.
We used to be these people on the barricades talking about this new technology. That's not really the case anymore. The level of maturity and understanding is much higher. Now it's of course translating that into projects and so forth. That is working on. But our view is that is increasing. Will it be you know, a 30% share of the insulated glass market, or will it be 3%? I don't know, but it's going to grow. That I'm sure of. You know.
Okay.
You also see the regulations on the market is also pushing the building companies and the real estate owners to our direction, I would say. So because you have the well-being and light, daylight, and also insulation and energy. So that's also why the interest is increasing, I would say, because of regulation. And the regulation is in Sweden and in Europe and the States also. I think it's a worldwide thing.
I think the tax incentive in the US now will be, for our industry, we being a small player, will be huge, actually.
Yeah.
So Patrick Labib has got a question. So would you switch off your
Thank you,
switch on your
Matthias.
microphone and try to ask your question, please?
Yeah, thank you, Matthias. Thanks, Frederick, for your presentation. You never address the problem of the cost of the technology, because I believe also that in the future, for sure, switchable glass has a bright future. But we know that a major break for the expansion of electrochromic glass, for instance, is the high cost of this technology. It's sometimes 800 euros per square meter. So, what is the position of the cost of your technology compared with these existing technologies?
I said where we are today. We are a small company and we are out now commercializing. We are price-wise on the same levels as many others. As we get the economies of scale in our production, we have some real opportunities to drive the cost down. So today we are still small, but we have an installed base here for 250,000 square meters. If we can start to get up a bit higher in volumes, our costs are very scalable. So I think that is the answer to the question to some degree. But right now, it's of course the chicken and the egg, how we get that.
Okay. And do you have a target? Let's say in future years for a cost of glass?
We have some targets. I have to watch myself a little bit because we are also we're small, but we're also publicly traded, and we haven't communicated any targets to the market. So there I have to be a little bit careful. But what is interesting, what we do, and I think this is an opportunity for the glass industry. If we compare the total cost over 20 years with like a traditional solar control solution with like an automated awning or static solar protection with dynamic glass. We use the same number from as the real estate industry uses. The cost is comparable, but you get some real advantages that you don't get with blocking off your views.
Yeah.
So
Maybe
I think
I'd like to say,
and of course partly cost. Yeah.
I like to get into that and like to answer that as well in some way. There is now, I think we're at a turning point as well, because the comparison very often is said, standard IG units cost whatever, 35 the square meter or so, and you are about 600 or 800, But this is not true. And it shows that we are at the turning point of what we are talking about products. Do we talk about a glass product which is switchable, or do we talk about a whole system which works together? In the end, you get rid of, with your switchable unit, you get rid of all this sun shading, which has to be installed, maintained, and repaired, which is not the case with your IG unit. So also in the future, if the glass people, really hope they take the opportunity, they could get deeper into the facade and provide a system rather than just the IG unit. And the other point is we have still the problem of who is building the facades. The facade, if you've got the big investors, they build a facade, they like to build it cheap and like to get rid of it for a good price. This is the problem, because they have not the interest of using expensive material. If you have a company who says, we have here a skyscraper, we like to build it, we like to use it, for them, these 800 euros or whatever for the square meter may be a really good price in comparison to all the maintenance costs they will save during these next 20 years. So with these guys, you can talk differently. And I guess this has to be solved. If this can be solved in a good way, that people understand it's not just the glass, it's about the whole system, and we go into this process and we really like to have it. And it seems to be there is the market pressure coming up now, especially with the rise of energy prices. That will be the point. So, Patrick, what do you like to say to that?
I totally agree with you.
Yeah.
But once again, when you compare a technology to other ones,
Yeah.
cost is one argument and one element, and you need to know what is the position. Of course, your technology has the big advantage is that for electrochromic glass, it can only be produced in certain factories. If we are thinking about the biggest one, which is Sage Glass, it's coming from the States, so it takes time and it takes money to get it. So your solution is probably better in the way that you inverse the process and you are sending the foil to the glass company. So I think that these are really interesting arguments, and for sure, yeah. I totally agree with your approach on with the economical approach, which must be more global. But once again, it was just since you were making some comparison with your technology and other technologies, just to know what was also the position in terms of economical arguments.
Yeah.
But thank you for the answer.
Absolutely. And thank you for the question,
Thank
Patrick.
you for the question. I mean, the question is thrilling, and I guess this will be how to say this will be within the glass industry the next 10 years. The question, at least, you know. I mean, as we see, it takes so long to implement new systems, and especially when you named Sage Glass. I mean, I remember 15, 16 years ago, I've seen Sage Glass on trade fairs, you know, and nothing happened within the years. And I guess within the last 2 years, there's really an increasing demand for things, and also projects being built in Switzerland a lot. I talked to the iRise guy last Friday, and I was in an opening in Darmstadt of a glass center, and there was an iRise, and said half our time we spend in Switzerland, because in Switzerland the people have to understood the you know, especially the big banks or whatever, who have to renovate and refurbish their old buildings, their old how to say administration buildings from the 80s 90s. They are using this material. I find this really good. So we've got two questions now. Malte is getting in, and Patrick. How important is it? Just a reference to answer. So who likes to get first? Malte?
Yeah, why don't I? Do you have experience in terms of durability of your foil? Either, you know, you mentioned these two projects, which are probably much too young to be, you know, have long-term experience, but do you have simulations, or how is that? Because that adds into the sustainability factor.
Absolutely. Very good question. One of the benefits with our foil working like a thin film battery is that we can also test it like a battery, actually. So we can simulate 20-year life by switching it, you know, on and off under temperature and UV conditions. So obviously the stability of the electrochromic material and the foil is extremely important. So every production batch or every combination of foil and electrolyte, we test for a 20-year life in our test facilities here. So to assure that we have the life and the performance and the stability of the product. So that we do, yeah.
So, okay, Patrick, you had another question?
No, in fact, it was the same. I wanted to have some information about lifetime of the technology, but I assume it is very similar to electrochromic glass, so you can switch 100, 1,000 times without any problem.
Yeah.
Okay, good. So I think we are coming to the end now. So I would like to say thank you for the speakers. I would like to thank you for the participants. I find it very good. We had a very good discussion. We were copying this this session here on video, so you can later see it. Malte will send out the information as soon as we have this online. This can take a couple of days because the upcoming class take next week, where we will also be present. So thank you very much, and yeah, I hope you will join in another time when we set another interesting series again.
Absolutely. Thank you all for participating.
Thank you.
Pleasure.
Frederick, can you hear me still, Frederick?
Yes.
Yeah.
Yes.
Can you send it your this PowerPoint to me also and
Absolutely.
information to me, because I didn't get that first mail what you said in the morning, but use it my Gmail address. Do you have that one?
I do. I have it. I'll check it again, and I'll send the presentation to you and Matthias.
Okay, good.
Yeah.
So thank you very much, and I will stop the talk now. And yeah, see you another time. Goodbye.
See you next time.
Okay.
Thank you.
Goodbye, everybody, and thank you.